All right, so we're going to talk about nonlinear and linear functions. So there are three ways you can tell the difference. The first is from a graph. So a linear function is a straight line. So the type of graphs that we've been seeing. The next way is from the equation, and your equation should have no exponents, and it should look like y equals mx plus b. If it's not in that form, then it's not a linear equation or a linear function. And then the third way is from the table. It should have a constant slope. So we still have to find the slope, but I'll show you a little bit of a different way to do that just to make it a little easier. But it should have increasing at the same amount. So those are linear. For a nonlinear from a graph, it's going to be curved. So it's going to be a curved or a non-straight line, right? And that'll make a little bit of a sense in a few examples. For the equation, these equations are going to have exponents and other symbols, such as the square root, a absolute value. So square root absolute value. Oops, spelling those words all sorts of wrong. I'm just gonna write abs value and put a couple of spaces there, so it's all in the same thing. All right. So square root and absolute values, those would be nonlinear. And then from a table, you can tell if it does not have a constant rate slope. So what that means is, like, say between two ordered pairs, you get a slope of 3, but then the other ones you get a slope of like 7. Okay, so those are obviously not the same. So that's how you tell. All right, so let's start looking at graphs. Okay, so let's start looking at the graphs. So in order for it to be linear, it needs to be a straight line. This one definitely has a curve, so it's going to be nonlinear. B does have a straight line, okay? And that's typically the kind of graphs that we've been working with, so it's going to be linear. Pretty much the answer to the difference is, have we seen it yet? No, it's nonlinear. If we talked about it before, it's linear, okay? This is a parabola. You might have been talking about those in science, and these are going to be nonlinear because they do have that curve at the bottom. So, okay, so again, a graph, it's either a straight line and linear, or it's curved and it's a non-straight line. So sometimes you might even see ones that are like a V shape. So yeah, they have straight lines, but they're not a straight line. So just be careful with those. From the equations, remember, ours, a nonlinear, has no exponents. Okay, so looking at example A, that has an exponent, so that's going to be non-linear. We're supposed to be writing function, but even writing non-linear, I'm too lazy for that. So looking at B, B is your normal y equals mx. There's no plus b, but it's implied 0, so that's going to be linear. I'm going to jump down to E. So we said up here that if it's a square root or an absolute value symbols, those are nonlinear. So this is a square root symbol here. So this is also going to be nonlinear. Okay. So, and I want you to take a second and try C, F, and D on your own. So take a moment and try C, D, and F on your own for me. All right, so hopefully you took a moment. I'm going to start with D because it was over here. So this one had an exponent, so that's why it's nonlinear. So it's an exponent, so it's nonlinear. C, if we've talked about those, they are actually vertical lines. So vertical lines are straight lines that are up and down, so those are then linear. And then absolute value, that's what these bars mean. That means the absolute value, so that's nonlinear. Okay. All right, so let's look at a table. These ones are a little bit more complicated, but I'm going to show you a way to do it without having to do the slope formula. All right, so I'm going to show you how to do it between the two. So what you're going to do is just take these two numbers, and what's the difference between 2 and 0? 2. What's the difference between 8 and 2? So it's 8 minus 2. 6. What's the difference between these two? What's 18 minus 8? 10. Okay, so we're finding the difference of our y values, which is the top part, and then we're going to find the difference of our x values. So it's going to be difficult to see. So what's the difference between 2 and 0? It's going to be 2. The difference of 4 and 2 is 2. And the difference of 6 and 4 is 2. So if this was going to be a linear function, these would all have to be the same, which they are. And these would all have to be the same, which they're not. So like, I'll show you in the next one. But yeah, so since these top 3 are the same, we'd say, okay, it's a function, but it's not really because of these bottom numbers. They would have all had to be 2, 6, or 10. So this is actually non-linear. So it's not increasing at the same rate each time. Okay. So let's look at B. Again, we're finding the difference. What's the difference between 0 and 5? 5. And by difference, I mean subtraction. 10 minus 5 is 5. 15 minus 10 is 5. Okay, so all of these are increasing at the same speed, same rate, okay? So let's look at this side. 20 minus 16 is 4. 16 minus 12 is 4. 12 minus 8 is 4. Okay, how about these? Are these the same? Yes, so both of those sides need to be the same in order for it to be a linear function. And this would have a slope of 4/5, right? Because it's y over x. Okay, so again, notice the difference. This one over here, not the same numbers, but these ones and these ones are the same numbers all the way throughout. So I want you to try C and figure out if it's linear or not. All right, so when I found the difference, I got 1, 1, 2, 2, 3, 9. Are these numbers the same or are these numbers the same? The answer is hopefully no to both of them. So since they're not the same, it's non-linear. What I just kind of want to point out is that the numbers for the x's and the y's, they don't have to be the same numbers between the two of them, but as long as in the same row, they're the same number, that's okay. All right, so that's our notes.